Hi everyone, my name is Bhavishya. In all our previous lecture, we have made a very good base of networking basics, fundamentals, and a bit more for our advanced protocols. So today we will start for our advanced algorithms, for our advanced protocols. So today we will talk about the dynamic routers. Before that, we will understand a brief about routing that we have learned in our previous lectures. So when we talk about routing, there are two types. One is static and second is dynamic. In static, we learned about a static route and default route. In static route, let's suppose our router used to ask, do anyone has assigned a specific path for me? And it used to go for that, right? Then we used to assign network and the corresponding next hop, right? In the default route, it used to ask, I don't have any address to go to. Do you have the gateway of last resort? And that way we used to assign it. In the dynamic routing, what we do is it asks for, did any other router tell you about this specific network? So basically in dynamic routing we have two types. The very first is our distance um, vector, and the second one is our link state. In distance vector we learn about RIP, that is our routing information protocol, and the second one is OSPF that we'll see in the later videos. Now if we talk about the RIP, so it is kind of a dynamic count. It is kind of a dynamic routing algorithm where we provide the information of other network dynamically. Now, as I said, it is based on our distance vector. If I talk about the algorithm that we use, that is Bellman-Ford algorithm. But for now, to keep it simple, if we talk about as it has originated from a distance vector, so what does this mean basically? So let's suppose this is distance and this is vector. We learn about distance first. So distance is about a metric. There is a metric that we use in our RIP, that is to specify the distance we use hop count. So let's suppose I am in router 1 and I want to see in my table that if I have any information of any router via RIP or not. We checked it, and there we see that we have, let's suppose we have we have the network address. After that we will have the administrative address, and then we have the hop count. Let's understand this. So administrative address for RIP is 120. So there are different types of protocol and we assign a administrative address for them. It is kind of a weightage that we are giving to a specific algorithm. We also have different value for our OSPF also. After that we have hop count. Hop count is a metric that we use to identify how far it is. So we have give it 1, so that means it is just nearby, just one hop. After that, that we see in our we'll see the exact in our implementation when we'll do the GNS 3. But for now, if I want to visualize and tell you what it is, after that we have the time allocated for that. After that it will tell us the network in through which it is coming, and after that it will tell via which interface it is coming through. So this was a brief. If I tell you more about RIP, so it is based on a rumor based. The way we used to play in our childhood, the Chinese whisper, that our neighbor used to tell us something, then we forward the same information to our neighbor. So it is more of like routing, routing by rumors, which is not very good. This is the reason why we use OSPF and BGP. But yeah, so this is how it came through. If we talk about RIP more, so it is intra-domain, which is we basically use RIP when it is when it is this single autonomous system, or we can say within the domain. If we talk about the configuration, how we configure our RIP. So in our GNS3, we'll go to our global configuration. There we will type the syntax router RIP. After that, we will specify the network and the IP address of the network. After that, it will happen. It will start happening. So this was a very brief about RIP. I attempted a little bit to give you a brief about RIP. In the upcoming lecture, we'll go detail about the RIP. We'll see the practical of it, and we'll see in detail. I hope you enjoyed this one. See you in the next one.